Hello guys, welcome to Ramta Solutions. Today we are looking at your arithmetic series. Of course, when we talk of series, we're talking of the sum of sequences, right? The sum of terms of a sequence. So without any waste of time, let's look at how to find the sum of this number here, 1 plus 2 plus 3. Maybe let me say the sum of it. Yeah, the sum of it. 1 plus 2 plus 3 plus 4 plus 5 plus and so forth. I will say up to 100 terms. In the previous video on sigma notations, we showed you how to simplify this how to write this in a compact manner. So today we're going to look at how to calculate the value, this value up to 100 terms. We're going to look at how to calculate this value. Okay, so let's consider a pattern here as T1 plus T2 plus T3 plus T4 and so on. All right, it'll be a lot of work, so we don't want to do that. Now let's do this. What we know, let me maybe say up to n terms. Up to n terms. Okay, so what we know, we know that the general formula for arithmetic sequences is Tn equals a plus n minus 1 times d. All right, so term 1 would be a plus 1 minus 1 times d, which is a. Term 2 would be, this is a, maybe let me write it like this, a plus 0d, which is a. Term 2 would be a plus 2 minus 1 times d, which is a plus d. While term 3 would be a plus 3 minus 1 times d, which we can say it is a plus 2d. Right? What about term 4? It'll be a plus 4 minus 1 times d, which we can say this is a plus 3d. Right? So you can see that we are okay with it. Now, let us maybe let's say, let the last term equal this L. Okay, equal this L. So obviously our last term would be Tn, which we will call it L. Remember, our last term here would be Tn. All right, so maybe here I can write it as plus, maybe let me say Tn minus 2 plus Tn minus 1 plus Tn. Right? So I will call our last term Tn, right? I mean Tn, and we will call it L. Now let's try to look at this in a different way. We had said T1 equals A. We had said T2 equals A plus D. I'm basically repeating this. We had said T3 equals A plus 2D. And we had said T4 equals A plus, what is it? 3D. I don't really need it. So we can continue and say Tn minus 2 Tn, and then Tn minus 1, and then Tn. We said Tn is L. Tn minus 1 will be L minus the common difference, while Tn minus 2 will be L minus 2 times the common difference. Okay, it'll be 2 times minus the common, it'll be L minus 2 times the common difference. Okay, now let's find the sum of these terms. Let's look at them. So we will say Sn equals T1 plus T2 plus T3 plus maybe Tn minus 2 plus Tn minus 1 plus Tn, right? We had said, I'm going to continue with Sn, sum of terms. We said T1 is A. We said T2 is A plus D. Yeah, we said it's A plus D. We also said T3 is A plus 2D. We then said Tn minus 2 was L minus 2D. When we also said Tn minus 1 was L minus D. And then we also said the last term is L. So we're going to call this equation 1. Now, let's reverse this order. We're going to reverse this order, okay? So when we reverse this order, we're going to say Sn. Okay, now in reverse, you're going to say it's L plus, remember it's reverse, L minus D plus L minus 2D plus ellipsis plus A plus 2D plus A plus D plus A, right? Plus A. So we're going to call this one here equation 2. Now what we're going to do, we're going to say maybe let's add these two. So we will add equation 1 and equation 2. So this will be equation 1 plus equation 2. If I add this and this, it is Sn plus Sn. They are the same. So we will have 2Sn. If I add this and this, I will have A plus L. If I add the second terms, I will have, as you can see, A plus L, D minus D. So I will still have A plus L. Right, I will still have A plus L. And here, 2D minus 2D, A plus L. So I will still have A plus L plus ellipsis. Even here, I will still have this plus this. I will still have A plus L. And this plus this, I will still have A plus L. Lastly, A plus L. Right? Now, as you can see, if I were to add two terms, there would be basically 2 times A plus L. If it is 3, it will be 3 times A plus L. So I should be saying there are n terms. So I can say 2Sn equals n times A plus L. Alright, I can say this is 2Sn equals n times A plus L. Alright, now therefore we can say the sum of terms when I divide by 2, it'll be n over 2 into a plus L. However, I remember saying this L is the last term. If you remember, we said Tn equals L, alright, equals L, which is a plus n minus 1 times d. So in place of L, I'm gonna put a plus into n minus 1 times d. Right? Now, this further simplification is n over 2, and then times 2a, a plus a is 2a, plus n minus 1 times d. Right? N plus 1 times d. Alright, so we have two equations here. We can use this one, or we can use this one. Alright, so let me do this. So when we use Sn equals n over 2 into a plus L, and we can also use Sn equals n over 2 into 2a plus n minus 1 times d. So you use this one when given the first term, okay, when given the first term and the last term. Okay, this one you use when given a sequence and I should say and able to find a common difference d. Alright, and able to find common difference d. And of course, you should also be given a. Right? So if you are given this, maybe I should also change this to series. If you are given a series or if you are given a sequence. So this is how you use these two equations. Remember, these are the two equations that you can use to find the sum of terms. Sum of terms of a quadratic sequence or sum of terms of an arithmetic sequence or arithmetic series. Right? You can use it. So as usual, this Sn is the sum of terms where n represents the term number. The information is not changing from what you know from arithmetic sequences. Now, let's try examples. We're going to try just one, and we're going to say, okay, what should it say? I think the example we should be saying, let me see what we should be saying. Okay, calculate the sum of the first 25 terms. Okay, for number 1 plus 2 plus 3 plus 4 and so forth. Number 2, minus 8 minus 5 minus 2 plus 1 and so forth. Number 3, 22 plus 17 plus 12 plus 7 and so forth. Right, so let's get on to it. So for number 1, For number 1, we have 1 plus 2 plus 3 plus 4 plus also and so forth. Now, we are looking for sum of 25. That's for you to know. We are looking for sum of 25, meaning our n is 25. Now, here we can see that our first term is 1. I think we can also say our last term is, because as you can see it varies with 1, it's 1, 2, 3, 4, so up to 25 terms. This means our last term could be 25. Alright, with this one in particular, because it's easier to see that the last term is 25. Otherwise, your common difference, as you can see, 2 minus 1, that's 1. Alright, so now let's calculate the sum of the first 25 terms. So they are Sn equals n over 2 into a plus 1, or you can say Sn equals n over 2 into 2a plus n minus 1 times d. So let's see. How many terms? We're looking for sum of the first 25. So it is 25 over 2. What is the first term? It was 1. What is the last term? We said it was 25. So I have to use a calculator here. 25 over 2 times 26, right, times 26. So it looks, the sum of the first 25 terms is 325, right? It is 325. Let's try here. So remember, you have two formulas you can use. So sum of 25 equals 25 over 2 into 2 times 1 plus 25 minus 1 times 1. Okay? Again, let's see with this one. 25 over 2, 2 times 1 plus 25 minus 1 times 1, right? It's still giving us 325, right? It's still giving us 325. So both of them work. We are okay, and you get your marks. Number two is -8 minus 5 minus 2 plus 1 and so forth. Again, we said we are looking for sum of first 25 terms. Number of terms are 25. Our first term is -8. What is our common difference? -5 minus -8 is 3. It's 3. So our common difference is 3. So we don't know the last term of this one. So what will we do? I will use this formula, equals n over 2 into 2a plus n minus 1 times d. What do we have? We said the number of terms are 25 over 2, and then we have 2 into -8 plus 25, oh boy, 25 minus 1 times +3. Let's look at it. Okay, so I am getting let me see. Okay, I'm getting 700. Right, I am getting 700. My calculator returns 700. 25 over 2 multiplied by negative 16 plus 24 times 3. Close the brackets. Alright, yes, it's 700. Then we are good to go. Now, the last one. The last one is 22 plus 17. Is it plus 12 plus 7 and so forth. As usual, sum of 25 is unknown. Number of terms is 25. Our first term is 22. Let's look at the common difference. This is negative 5, negative 5. It's still negative 5. 7 minus 12 is negative 5. So it means our common difference is minus 5. So we have Sn equals n over 2 into 2 into 2a plus n minus 1 times d. Therefore, we have 25 into 2, and then we have 2 into 22 plus 25 minus 1 times negative 5. Close the bracket. So let's get into it. This one is 44, 24 times minus 5. I hope I'm doing the right thing. My calculator returns negative 950. Okay, my calculator returns negative 950. This is the sum of the first 25 terms of this sequence. Okay, all right guys, with that being said, it's a wrap and see you next time. Bye bye.